Today's notes are on distance formula. When we use the distance formula, we are technically connecting two segments on a coordinate plane, and we are finding the distance between them, which is the same as calculating the length of the segment that connects them. So if one of our points is x1, y1, and our other point is x2, y2, and we're looking for the distance between them, we are technically finding the length of the segment that connects them. To use distance formula, d equals the square root of delta x squared plus delta y squared. To use that, we have to know what delta x and delta y stand for. So delta represents change. So delta x means the change in the x's, which means what's the difference between them, so we subtract them. Delta y, therefore, means the change in the y coordinates, or what do we get when we subtract them? You want to make sure you're subtracting in the same order. So for instance, if I am subtracting x2 minus x1, and I'm going in this direction for x's, then I have to subtract in that order for y's as well. It doesn't matter which order you subtract in as long as you're consistent. So in the first question, they are asking for me to find the distance between this pair of points. So I have x1, y1, and I have x2, y2, and I'm going to go through and calculate the distance. When I do that, I substitute into distance formula, change in x squared plus change in y squared. In for delta x, I'm putting in 8 minus negative 5, so that's from the x values. So 8 minus negative 5. And then negative 4 minus 6 for the change in the y values. A change in x's are in parentheses squared, change in y's in parentheses squared, all under the big square root. So you want to make sure you have that big square root through the whole entire problem. So in this case, d is equal to, and this is two negatives next to each other, so that's a plus, so that's 13 squared, plus negative 10 squared, which gives me the square root of 169 plus 100 when I do that math, which means that d is equal to the square root of 269. If that radical could be simplified, you should go through and simplify it. In this case, however, there's nothing that you can do, so we're going to leave it like that. For part B, we're going to go through and do the same exact thing. So on this particular question, I am finding the distance between these 2 points. If it helps you to put x1 and y1, x2 and y2, feel free to do that. In here, change in x squared plus change in y squared. I'm going to go back now and substitute in. Notice I'm showing all the steps. I've written the formula. I put every substitution in there. Somebody looking at this needs to be able to see exactly what it is that you did. So in this case, I get distance equals the square root of negative 7 squared plus negative 10 squared, which gives me the square root of 49 plus 100, which means that d is equal to the square root of 149. And again, that cannot be simplified, so there's nothing else that we're going to do with this particular question. If you could simplify the radical, you must go through and do that. So there's a lot of different scenarios of when we're going to use distance formula. A couple of them are here on your paper. So for the first question, they are telling us that we are going to use the distance formula to prove that a parallelogram with these vertices that you see here is indeed a rhombus. So they tell us it's a parallelogram. Our job is just to prove that it's a rhombus. One of the ways to prove a parallelogram is a rhombus is to show that two consecutive sides are congruent to each other. So I'm going to show two consecutive sides congruent. So the first thing I'm going to do is I'm going to go in and I'm going to plot these points and get a visual of what's going on with my parallelogram. So I have -7, -2. So here's where that point is. And I'm going to label that J. And then I have K, which is 0, 4. L, 9, 2. And then M is 2, -4. I'm going to connect them to make a parallelogram. And my job, if I'm showing that this is a rhombus, is to show 2 consecutive sides are congruent. It's my choice on which 2 consecutive sides it is that I want to work with. So I'm going to pick to work with showing that JK is congruent to KL. So I'm going to first do the distance between these 2 points and then do the distance between these 2 points. So when I go through, I'm finding the length of JK, and when I go through and do that, and notice here, instead of putting the D, I actually put JK. When I go through and do that, I'm using distance formula, so change in x squared plus change in y squared. And I'm going to go back and substitute in. So when I substitute in for JK, this is 0 minus -7 squared plus 4 minus -2 squared, which gives me 7 squared plus 6 squared, which is the square root of 49 plus 36, which is the square root of 85. Now the square root of 85 can't be simplified either, so I'm just going to leave that measurement there. And I know that when I now go through and find the length of KL, that KL has to turn out to be the same. So I'm going to go back and plug in for KL. I'm not going to rewrite the distance formula in this case. As long as it's written once per problem, I consider that acceptable. So I'm going to substitute in, so I have 9 minus 0 squared plus 2 minus 4 squared. When I go back and simplify that, I have 9 squared, which is 81, -2 squared, which is 4, and I end up with the square root of 85. This is telling me in this particular problem that I'm supposed to prove or show that this really is a rhombus, which means that my final step for this actual proof is to now go back and write a little summary statement. So in my summary statement, as summary statement, I am going to write, since the distances of JK and KL are equal, JK is congruent to KL. And then since I have these 2 consecutive sides that are congruent, I know that parallelogram JKLM is a rhombus. So when we're working on these kind of proofs, part of our job is to make sure that we show the math that we did. That would be the section in here where we calculated the distance formula. And then we have to write a little summary that does explain what it is that we were thinking when we went through and did that. For question number 2, you'll notice that when you look at the coordinates that are given to us, we have what we call literal coordinates. In other words, I don't actually have numbers in there other than 0. It's A's, B's, and C's. So I need to draw a parallelogram, label it A, B, C, and D, and I don't know what those letters are, so I can't actually put that on the graph. So I'm going to improvise, and I'm going to just make a parallelogram looking shape because that is what I'm proving. And I'm going to do A, B, C, D. So A is 0, 0, B is A 0, C is B plus A, comma C. This is the whole x coordinate here. And then D is BC. If I have to show that this is a parallelogram using distance formula, what that means is that I have to show that both pairs of opposite sides are congruent. That means that I have to show that DC and AB are congruent, and then I also need to show that AD and BC are congruent. So I'm going to work this in pairs. In other words, I'm going to go through and I'm first going to work on AB and DC and show that they're congruent to each other. So in this particular question, the length of AB, I'm going to use distance formula. When I substitute in, it's the change in the x's. So that's going to be A minus 0. And then the change in the y's, which is 0 minus 0. Which means that I end up with the square root of a squared plus 0, which is the square root of a squared, which we know is just a. So the length of AB is a. That means that if this is indeed a parallelogram, we know that the length of DC also has to turn out to be a. So I'm going to go back, substitute in. DC, remember it's this x value minus this one. So it's b plus a minus b squared plus c minus c for the y value squared. And when I go through and evaluate this, I want you to notice that the b's cancel. It's b minus b. So they cancel out. So what kind of starts out looking like a mess simplifies relatively quickly into exactly what we had over here. So because of the work that I just did, I know that since the distances are equal, AB is congruent to DC. That's one pair of opposite sides are now congruent. Now I'm going to go back and I'm going to do the same thing with the other two sides. This is a little bit longer of a problem. We're in charge of showing all of our work for this. So I go back now and I'm going to calculate the length of the other two sides. So I'm going to calculate the length of AD and I'm going to calculate the length of BC. So when I do AD, I subtract the x's, b minus 0 squared, plus subtract the y's, c minus 0 squared, which gives me the square root of b squared plus c squared. I want to take a minute here and let you know that this is considered simplified. You cannot simplify that further by square rooting both the b squared and the c squared. If this particular problem was the square root of b squared c squared, where there was just one term, you could get BC. But if you have the square root of b squared plus c squared, you cannot square root them separately because of this plus sign that's under here. So this is considered simplified completely. Do not do any more simplifying. We do know, though, that if that's what the length of AD turns out to be, then we know that BC better turn out to be the same thing. So I'm going to calculate the length of BC. When I subtract the x values, I have b plus a minus a squared and c minus 0 squared, which gives me, and again, I can simplify here. These a's cancel, so b squared plus c squared. Again, that can't be simplified. And I want to make a little note now that says, since the distances are equal, I know that AD is congruent to BC. So I've made two little mini summary statements. One where I went back and I said, okay, I did distance formula on the top and bottom sides. I got A for the measurement for both of them. They're congruent. And then I did the measurement of the other two sides, opposite sides. I got their measurements both to be radical b squared plus c squared. So right now, I know that both pairs of opposite sides are congruent. if that's the case, I need to make my final summary statement now, which says, since both pairs of opposite sides are congruent, quadrilateral ABCD is a parallelogram.